Okay, in this video we're going to go over 7.2 and 7.3. So the title is the mean of a random variable, also known as the expected value. Okay, so this says expected value, and mean, know that that just means the average. Okay, we've already done this. We're going to summarize everything right here. So it says, look back at Nikki's one-on-one situation. For 100 outcomes, she has 40 outcomes with 0 points, 24 outcomes with 1 point, and 36 outcomes with 2 points. So what total number of points would you expect Nikki to score in 100 trips to the free throw line? So we did this expected value, right, on the other page. So I'm just going to put it right here so that we can compare it to the other Nikki. So if you remember, that was 96 points. Then, what would Nikki's average points of, what would Nikki's average number of points per trip be? This is the expected value for the situation. So the average per trip, so 96 points for 100 trips, that's going to be 0.96. Okay, so then let's talk about expected value or mean of a random variable. So notice that this is expected value and this is mean. They mean the same exact thing. So to get that, you're going to sum up all of the points times the probabilities. So this is what we did. We said to get 0 points, it was 0.4. To get 1 point, the probability was 24 out of 100, right? To get 2 points, it was 36 out of 100. Okay, so this is called a weighted average. So let me talk about each of the weighted averages we've done so far. So remember, Nikki's weighted average with the one-on-one was 96 points. Nikki's weighted average with the 2 shots was 120 points. And Nikki's weighted average with the 2 shots, and that's the other Nikki, N-I-K-K-I, was 160 points. So all of these things you can call the weighted average, you can call them the expected value, or you can call them the mean of the random number. Okay, so let's go on to the next page. Okay, now they go through a whole nother problem set, which is really well done, I think. So the textbook is a good thing to read over again. These notes are good as well. You may need to do both of those things to get a full handle on this. So it says, Mr. Fujita hires Tassa to mow his lawn for the summer. When Tassa asks how much he will pay her, he offers 2 options. Mr. Fujita pays Tassa $10 each time she mows the lawn. So that's her first option. Option 2, each time Tassa mows the lawn, she will roll a pair of number cubes. If the sum on the cubes is 7, Mr. Fujita will pay $30. If the sum is not 7, he will pay her only $3. So evaluate the 2 options. So by evaluating them, we want to figure out what the expected earnings would be. So option 1, for each time she mows the lawn, her expected earnings is going to be exactly $10. No options, no variations. Okay, so, but if she takes the second option, what is her expected value then? So remember, he's going to pay her $30 if she rolls a sum of 7. So how many times does that happen? So right here, I've done that table that we did previously for the die. So remember, 7 happens the most times. So here's 7 right here. So out of 36 times, 1, 2, 3, 4, 5, 6 is going to be a 7. So over here, I'm going to say 6 out of 36 is going to be a 7. Therefore, 6 out of 36 times, she'll earn $30. Okay, let's reduce that 6 over 36 to 1 over 6. 1 over 6 times, she's going to get $30. So what's the other probability? 5 out of 6 times, she's going to get 3. So what is her expected earnings? So we're going to call this EX, okay? Her expecting earnings for option 2 is going to be 1/6 times 30 plus 5/6 times 3. So 1/6 times 30 is 5, and 5/6 times 3 is going to be 15 over 6, which is what, 250. So her expected earnings are 750. So if she was wise, she would not want to hedge her bets and just go ahead and take the $10 per mowing event. Okay, so that's options 1 and 2. So I thought that was kind of interesting how you can use expected value to compare the two situations. Okay, let's go on to the next page because there's more discussion to follow. Okay, so then under 2, he now proposes 2 other things we want to consider. So these are options 2A and options 2B. So he will pay her $30 if she rolls a sum of 7. Okay, so we knew that, and that's going to happen 1/6 of the time. Okay, so her expected earnings are going to be 1/6 times 30. Then it says, how much should he pay her if she does not roll a 7, if he wants her expected mean to be 10? Okay, so this has to be 10. So we're going to take the 5/6, which is the other probability, times some mystery x. And when we solve for this mystery x, this is how we're going to do it. So 10 minus 5 is 5. So 5/6x equals 5. Multiply both sides by 6/5. And for that to be the case, he should pay her $6 the other times. So if she rolls a number other than 7 and he pays her $6, then she would have the same expected earnings as in the first scenario when he just pays her $10 a time. Okay, so I thought that was kind of interesting. Okay, next one, option 2B. Option 2B says, okay, he will pay her $3 if she does not roll a sum of 7. Okay, so how often does that happen? That happens 5/6 of the time. He's paying her $3. How much should he pay her if she rolls a 7 if he wants her expected mean to be $10? So remember, 1/6 of the time she's going to roll a 7. And he wants the expected mean to be $10. So let's figure this out. So this is 15 over 6 plus 1/6x equals 10. So 15 over 6 is like 250, right? 2 times that is 12, yeah, 250. So that means that 1/6x equals $10 minus 250 is 750. Multiply that by 6, multiply that by 6, and I get that x is going to be $45. Okay, so she's going to get $45, that 1/6 of a time, when she does indeed roll a sum of 7. Okay, so these are 2 modifications of option 2. So he wants her to have that expected value, so he has to figure out a different payment scheme for each of these 2 options. Okay, so let's go on to the next page and we'll do more of this analysis. Okay, so here we're back to option 2A. So what's the probability that she's going to roll, that she's going to get paid $30? So let me just go back for a second. So yes, so here it is, 1/6 times 30. So let me fill in my chart. So the probability of getting paid $30 is 1/6, and the probability of getting paid $6 is 5/6. Okay, So this mu right here is the expected value. That's 10. So figure out what the deviation is from the x to the expected value. 30 minus 10, that deviation is 20. And 6 minus 10, that deviation is negative 4. Okay, so now we're going to do something different. Let's figure out the variance. So the variance, you just take the deviation and you square it. So if you square a 20, you get a 400. And if you square a negative 4, you're going to get a 16. So there's more variation from the expected value in the case where you're earning $30 than in the case where you're earning $6. Okay, the spread is greater. Okay, so variation and deviation measure the spread. Okay, so these both measure the spread of your x from your average or mean. So if you have a large deviation or a large variance, then that means that you are a large distance from the mean. Okay, so that's kind of intuitive. Okay, so variance is a kind of weighted average of the squared deviation, with each being weighted according to its probability. Okay, so that's what variance is. It's a weighted average of the squared deviations. So here is your variance formula. Okay, so you would take, well, first off, this is sigma squared. That's what that's called. So you could take the sum of all the deviations and square it times the probability. Or you can take the sum of the x squares times the probability and subtract it from u. Either way, you would get it if you did this by hand. Okay, so variation is the squared formula. Standard deviation is going to be the square root of the variance. Okay, so no matter how you get your variance, taking the square root will get you your standard deviation. Okay, another thing you want to know about. Z-scores for a value of a random variable. A lot of times people use Z-scores. Z-scores have the benefit of having mu equal to 0 and standard deviation equal to 1. So it's kind of a uniform way of comparing numbers. So let's just take a second and we're going to figure out the z-score for 30 and for 6. So look what the formula is. So the z-score for 30, and this tells you how far away it is from the mean, equals 30 minus 10 over the square root of 80. So that is about 2.23. So if you have a normal, this kind of gives you a normal distribution. Here's your mean of 0. Here's your t-score of 2.23 here, and that would be the 30. Okay, you're just normalizing it. So then if we have z of 6, by definition, that's going to be 6 minus 10 over, same thing, radical 80, and that gives me a z-score of negative 0.4472, and that indicates that it's below the average, which is something we already know. Okay, so that's just a little insight into z-scores. Okay, we want to get back to calculator work, because we can do these variance formulas and standard deviation formulas by hand, but there's no need to do that when you have a calculator. So you're going to need a graphic calculator like a TI-84 or a TI-83, or you can use the one on your phone. I believe it's going to work there as well. So let's say we want to figure out the variance here, and we do not want to do it by hand. This is what we do. you are going to go into your calculator, and if you look at the stat button, so it's towards the top, so I'm going to get out of what I have, just go into the top and hit the stat button. Okay, it's really close to the top of your calculator. And then go to edit. So I went stat, edit. So then I see these tables. If you have anything in it, you have to clear it by using your up arrow and going up to the L1 and then hit clear. Do not hit delete. Okay, so now I have blank L1s and L2s. So in my calculator, this is what I'm going to do. I'm going to put my X's in my L1, and I'm going to put my probabilities, also called frequencies, in my L2. Okay, so go ahead and do that, and I will do that as well. And then I'll tell you what's coming next. Okay, once they're in there, then what you're going to do is you're going to hit stat again, and you're going to go up to the top, and you're going to go to calc, and you're going to do one var stats. Okay, it says list. You want your L1 to be in the list. So to get those letters, if it's not filled in already, you're going to go to alpha and then hit the number 1. That will get you L1. Because your list is L1, use your down arrow, go to L2, go to frequency list, and then you're going to say alpha 2, which will get you L2. And then you're going to say calculate, and wonderful things are going to happen. Okay, so look what I have. I have a couple of things I can read. Okay, X bar is important. X bar is my expected value. So that's my 10. That's my mean. Okay, that's my average. Then I have the standard deviation of X. And that is 8.9443, which is the square root of 80. All right, so I can just get it from my calculator without having to do these by hand calculations. And in our class, I would like you to be able to do it with your calculator. Okay, so I wanted to do a couple of more little things. I wanted to talk about the area model for the earnings for Model 2A. So, and that's what this is. So this problem has been 2A. So I'm going to go back for a second, and let's see if I have a table. I may have to go back one more. Okay, remember this table? Well, this table, instead of having the die, why don't I go ahead and write in the earnings? So let me erase this. Okay, and what I'm going to do is I'm going to say, all right, wherever I have a 7, those are going to be all my 30s. Okay, because when I roll a 7, I'm going to get paid $30. But when I roll everything else, what do I get paid? I get paid $6. So those are all my 6s. So you can display your earnings on this grid. Because once I know what the rules are for my earnings, I can then just fill it in, and it represents the probability of these earnings. Okay, so I just wanted to point that out to you. So let me go back to where we were in the notes. So coming back over here, they then talk about the second option. Okay, so the second option, it says, find the standard deviation for Y. Okay, so you can't see what the top is. Put values in L1 and probabilities in L2 and run one variable stats. So they're not even going to do it by hand this time. Okay, so I'm going to do this stuff down here, and then I'm going to do these problems someplace else. Okay, so here in your L1 for scenario 2, your data, remember, was $3 and then $45 if you roll a 7. The probability of getting paid $3 was 5/6. The probability of getting paid $45 was 1/6. So this goes in your graphing calculator. So given that you're putting in your graphing calculator, it says find the standard deviation for Y. So I'm going to find the standard deviation, and I'm going to run it, and what I find is the standard deviation is going to equal 15.65. Because remember, I ran it as one var stats, and I said the list was L1, and the frequency was L2. And I wanted to find X bar. And what do we get for X bar? So maybe I have to run this. So let me just do this. So we know that the X bar has to be $10, right? Because that was the expected value, and that's how we figured out he'd have to pay us $45 the times that we rolled a 7. So the X bar is 10, which is the same X bar for option 2A. So now your standard deviation in this situation is going to be 15.65. So that standard deviation is a lot bigger. And that should not surprise us, because isn't this a lot bigger difference than were the 30 and the 6? Okay, so now they say find the z-scores for the two possible options. So let's find our z-scores. So remember, to find the z-score for 3, you're going to take your x, which is the 3, minus your mu, which is the mean, which is the 10, over the standard deviation, which is the 15.65, and you should be getting negative 0.45. That means that that's below the mean, and that's correct. Okay, your z-score for your 45 is going to be 45 minus 10 over 15.65, which is 2.24. And that makes sense, because what these scores do is they center things around a mean of 0 and a standard deviation of 1. And if you switch it to that, you will then get the values of 2.24 and negative 0.45 respectively for scores of 45 and 3. Okay, so I believe, interpret the results. The scores with the z-scores that has the greatest absolute value is the furthest from the mean. That's what you would say in terms of interpreting your results. Okay, so there are two very good problems. One is problem 3 and one is problem 4, and you can find them on page 199 in your textbook, and we will do that on the next page. We'll do it in the next video. So this ends this video.